Hey there, it's that coding guy here. This video is going to kick off a little series on APIs. And if you want to get started building APIs, this series will help. But I wanted to start off with a conceptual, high-level video so that we know the concepts in play before we really dig into building an API. So I've got some topics over on the left here that we're going to dig into. And the first one there is 3-tier or N-tier architecture. So I've got this little image here on the screen, and this is splitting a system into 3 different tiers or layers. We've got the UI, which stands for user interface, the API, which stands for application programming interface, and DB, which is the database. You're probably familiar with the UI because you use them all the time when you're surfing the web. So user interface is made up of text boxes and radio buttons and input fields and submit buttons and drop-down menus and other expanding menus that we select things from. Every time we go shopping online or update some of our information, we're making use of a user interface to do so. And if you're not sure, you never thought about it, the UI doesn't do all of those things on its own. It's actually sending requests to other computers and other processes in order to get things done. Usually the UI just kind of validates some of our information, and then it makes a request to an API. And that API then checks it again, makes sure all of the information that was submitted is correct according to whatever business logic there may be. Maybe it's validating the state input to make sure that we input a valid state. Maybe it's checking to see that our hotel reservation end date doesn't occur before our start date or something like that. And so it's really checking all of that stuff over. And if all of that is good, it will contact the database in order to persist new information or updated information, or maybe we're deleting something. And then the database does what it needs to do. Because in the end, the database is the final system of record in most cases. The computer that updates or actually dealt with our user interface is a totally different computer usually than is actually storing the data in the end. And it goes through this process. And so that's 3-tier, with each of these being a tier, right? And we can get into N-tier later in the future a little more, but the crux of it is that even these tiers can be broken down further into other tiers. So we could think about the UI as being broken down further into different tiers, and that's how we kind of get to N-tier architecture there. And there can be other things in between these guys too. So that's 3-tier architecture. And then let's talk about request response lifecycle. So when the UI wants to get something done, like we update our address information, say, it sends a request to the API when you hit the submit button, assuming everything was valid. Any validation generally happens on the front end, and if you've ever entered something into a field and hit submit, and it's like, oh, that's wrong, please, your password must meet these criteria, it has you resubmit. Once that validation is good, it actually contacts the API. And the API generally checks it again because maybe there was a bug in the UI as far as its validation goes. So the API is going to check it again and make sure everything is good. And if it is good, we want to update our address, it contacts the database for us. It's making a request. So those requests all happen over HTTP, which is a whole other topic in itself. But we're basically sending messages over the internet. It says, hey, do this. The database is like, all right, I've got it. I saved it. So it would be pretty bad if the UI sent all this stuff to the database and the user never got any response back, like sending something out into the void. You're like, hopefully my stuff got updated. So what happens is, this is request response lifecycle. So we're going to start generating a response. The database actually sends a response back to the API. It says, hey, I updated that thing. That was successful. Or not. And the API then responds back to the UI for its original request. It says, hey, this was successful or not. And then generally the UI will do something with that information. Maybe it pops up a little notification and says, hey, you were successful, or you weren't successful. Please try again later. There's a problem on the system. If it continues, contact an administrator or something like that. But all of that stuff that happened is the result of one action being taken on the UI, somebody hitting the submit button. And all of the rest of these requests and responses are all generated from that. So let's talk about client-server architecture. What's a server and what's a client? You can think of a client as a thing that is making a request. It doesn't have to be a person, actually. When the API contacted the database and said, hey, save this, it was the client for this call, right? Now, it had a client, and the client for that was the UI, because the UI sent that. And then it was actually the user in the first place who submitted the submit button, or clicked the submit button. So it's a little weird. So the client-server architecture is basically laying out the idea that one thing is going to make the request of another from like a centralized computer. And so that's client-server architecture. And now all these things are kind of overloaded in a sense that they kind of overlap. It's hard to understand sometimes where one begins and one ends, and all these terms getting used interchangeably. Though it's okay if you feel overwhelmed. Just keep plugging away at it, ask questions, do your research, and dig into it, be curious, and you'll get there. And the other thing we didn't really talk about too much is, what's a server? And I like to boil it down to the idea of a server is a long-running process that is waiting for requests. It's listening. And I think that's a pretty good definition in the end. There's a lot more complicated things that we could say probably about a server. But it's just a long-running process. It's usually running on a computer somewhere, right? But, one computer can host several servers. Like I've got my box right here. I could have a dozen APIs on it ready for requests and things like that. So it's dangerous to think of a server as a computer. I think a computer can host several different servers. So, if a server is running, if that long-running process is running, and nobody ever makes a request from it, it's just going to keep running. It's not really doing anything except listening for requests. And then once it gets a request, it's going to spring into action. I think about it kind of like maybe a draft horse or something. If we don't tell that draft horse what to do, it's just going to stand around and use some resources. And, it's going to eat some hay and just chill out. But once we say, hey, let's plow this field, then it's going to start doing its work, So hopefully that helps understand a little bit of the atmosphere in which we're going to be doing things. So an API in general is going to expose different things that it can do to the outside world. I like to think of them as levers that we can pull. You know, if we think about the API as a black box and it's got these levers sticking out of it, it's going to let us do those things, and that's all it's going to let us do. And then those things might be like create a purchase. So if I want to buy something off Amazon, I could do a purchase, and then we're going to pull the create purchase lever. But it's like, it's not going to allow me to go in there and change my account number to whatever I want, or give myself a whole bunch of free credits on my account, because those aren't levers that it lets us pull. So we don't have full access to the database, and that helps us as developers. It helps us design secure systems when we only expose certain functionality to the outside world. In future videos, we'll dig into how to do this in code using Spring Boot. Look forward to those videos then. But for now, we'll see you later.